So for the next thing is we'll talk about the rate. So for rates, maybe sometimes we want to know like the rates can means how fast a thing is increasing or decreasing, or it can means a ratio as well. So for rates like in daily lives, the speed can be a kind of rate because we know that the speed represents how fast we are moving per second, kind of things like that. And while we are moving per second, it looks like some fraction things. So it's also can be changed to a ratio form as well. And similarly, we can have maybe want to purchase for some fruit, maybe some apples, and how we pay for the apples is weighted by its weight. So maybe how many, like for 1 kilograms of apples will need maybe $6 here. So we also have a ratio thing related from the weight of the apples or fruit to the price we need to pay. So by those kind of ratios, we'll call them as rates, not ratio anymore. And in the future, we'll use rates and a lot of rates in our future study as well. As especially for this case, we are learning more about the linear relationships, and for linear relationships, it's rate related things. So let's think about the maybe let's take a look at this first example. Is we have some Olympic sprinters and it runs for 800 meters in 10 seconds here. We want to know about how fast he runs. So while we're asking for how fast, it might be asking for the speed or maybe the velocity. And actually there's differences between speed and velocity, but it shall be explained in grade 11's physics as well. So so far we can just say that those are just some like how we measure about how fast something is moving or something is running. So how we think about this problem is first we want to think about how far the sprinter runs in 1 second. And how we think about it, we just divide it by 100 meters evenly between the 10 seconds. So I should highlight all the things here. In 10 seconds. So the calculations here will be the sprinter speed equals to 10 meters per second, because if we are dividing it, we'll have color here. So this is calculated by 100 meters evenly divided into 10 seconds here. And we'll get 10 meters per second. And we can also always write the units, the fraction units for the fraction ratio by meter per second as well. So that's how we get the sprinter speed here. Any questions so far? Okay, so what we can do, this is just like a more specific drawing for that. So yeah, so that's basically some ratio things, like rate things related with the ratio. So it's basically expressing how things is increasing or decreasing. In this case, it's be increasing. And later we'll talk about why sometimes a thing can be decreasing, having a negative rate as well. So the next thing is sometimes we want to simplify the rates as well, because while we have maybe in this case, we'll have like be an example of a speed of a car, maybe have speed of 180 kilometers in 3 hours, but we maybe want to know about the speed in 1 hour, or maybe in 1 second or 1 minute as well. So sometimes, or for most of the times, we need to simplify the rates as well. And in this case, how we calculate speed will still be the distance traveled, so 180 kilometers here over the 3 hours. And how we calculate it will be 60 kilometers per hour. Or we can write it as km per h as well as the speed here. So you can see that the compound units or the units simplified here will just be some kilometers per an hour as the units after we are simplifying the rates here. Any question about it? So while you can see that there's a kilometer per hour, it basically means that we have some kilometers, some kilometers per 1 hour. We are just simplifying the 1 and combining the 1 hour into the unit thing as well, because for most of the scientists, it's well looks nicer, and it's well just maybe we are for most of the time we are lazy and we don't want more like one numbers or units numbers here to confuse the calculations as well. And later we also talk about the units rate as well. So this is something we can deal with the simplifying rate. And the next thing is how we will convert rates in different kind of things. So in this case, it will be literally similar to the things we are converting from gallon to liter or from liter to gallon as well. For me, from miles to kilometers or kilometer to miles. So the first thing, like the easiest one will be the time converting. So the first thing we can convert is, we want to convert is maybe from the 60 kilometer per hour, changing to some unit measurement of minutes. So first thing we want to do is using the fact that 1 hour will equal to 60 minutes. Any questions here? I was supposed I would know that there's like 60 minutes in an hour. So after knowing that, we can list a equation where we first have the speed equals to 60 kilometer per hour. Oopsie, I want to change this. It's nicer. And now I can change it to 60 kilometers per an hour. It literally means the same things here. And we know that an hour can be replaced by 60 minutes. So I can change the an hour to 60 minutes here. So here we are using the fact that 1 hour equals to 60 minutes. And after that, I can move these 60 minutes out, where is the denominator part, and keep the units same. And then I can calculate the numbers here to simplify it. So we know that this will actually be 1 kilometers, and I can always change it to the per, like kilometer per notation instead of the fraction as well. So I'll have 1 kilometer per minute as the final calculation. And this will be the same speed as previous one, just with different units here. So that's how we can convert rate or converting minutes as well. Any question about converting here? And now I can simply use this new rate or new speed to calculate the distance. So I can know that's 1 kilometer per minute times the 7 minutes will be 7 kilometers, where is the distance traveled for the car. Any questions about the calculations here? Oh, good. Okay. So these are just like more specific steps here. And there's are some like handy conversions for some common used things as well. So 1 meter will equal to 800 centimeters or cm. 1 meter will equals to 1,000 milliliters as well. And 1 kilometer equals to 1,000 meters. Actually, I usually prefer to use the simplified version. So 1 meter equals to 100 centimeters. 1 meters equals to 1,000 milliliters, and 1 kilometer, which is km, equals to 100 meters, 1,000 meters here. And 1 liter, which is just 1 L, equals to 1,000 milliliter or ml as well. And an hour, which is 1 H, equals to 60 minutes. And 1 minute, well, equals to 60 seconds as well, or just S. So those are just common like facts of the unit conversion here. Any question about the common units here? Okay. So I have like a practice problems. So for the practice problem, I have rate where it is having meters per second. I want to change it to meters per second first, which is the unit rate of the meters per second, of course, and then the unit rate of meters per and units here. Yeah, so for the first one, maybe we want to say that 240 seconds equals to 4 meters, minutes here. So we can say minutes. And then we did the calculations. So it shall be 48 meter per minute. That's something correct here. So yeah, I would say well done for this question. And also always there's another way to think about it is we can also, like I will try another steps as we can also say that's the unit rate will equals to 190 meters per. Still we want to say the same thing because it is like always the same ratio for it. And then we want to change the second to some minutes here. So if we want to change the second to some minutes, like we want to change the like the second notation of the units in denominator into minutes. So how we need to change it? We want to divide it by minutes, but we cannot just directly divide it by minutes. What we can do is we can also times a second here to cancel out the 2-second notations here. But we cannot directly times something here. We don't know about the amount we should times here. So we should always times some one value to make the equation satisfy the conditions here. And what the number of zeros will be just 1 minute, well, equals to 60 seconds. And we just calculate the numbers here. So it will be 190 over 240 times 60 over 1. And the units will directly becomes meters per minute. And the calculations here will be the same, like we'll produce the same result, which will just be 192 over 4 meter per minute. And it will just be 48 meter per minute here. So this is a second approach, but this approach will be much complicated. So what we're thinking is we just can directly substitute or replace the first, like the second by the units we want using the unit conversion here. Okay. And next we will have the negative rate, and we don't have much things to say about the negative rate because we all performed great jobs on understanding the negative numbers over number lines. So the rates can also be a negative, and while it is decreasing or it is a loss. Like when a rates represent a loss or decrease, it will be a negative values here. So for example, if we are losing maybe like $180 each days, actually not wait. For this one is for the first example, it was while we are earning $180 each day. And the rates or the money we are earning will be $180 per day. But if we have to pay maybe some tolling fees or to commute to work, then we will lose $6 per day. And the rate of loss will represented by -7 per day. It's represented the loss here. And the first one will represent earning here. So that's what some negative rates can mean. And similarly, the negative rates can also mean some like opposite directions. So while we are moving maybe with a negative speed, moving negative 10 meters per second, we're just moving to the opposite direction from the positive axes here. So if we have a speed of negative 10 meters per second, we might definitely running into the opposite direction. We're running toward the negative number line directions here. So that's what be the negative rates, like what negative rates represent. Any questions about the negative rates here? That's correct. And we can always like, there's another way to think about like to solve the problem is we can always use what we get previously. So maybe for the second question, I can also reduce, like for question B, I can reduce it by using 0.03 liter per minute. So 0.03 over 1, I can say liter per 1 minute and change it to 0.03 over 1 times 8,000 milliliters per minute as well to do the calculations. So here we are actually just directly multiplying it by 1,000, changing it's 2 milliliter per second per minute as well. And you can see it also equals to 30 milliliters per minute. And for last questions, I can use this 30 milliliters per So it will be 30/1 milliliters per minute. And I want to change the denominator to some second unit and keep the same of the numerator. So by changing it, I need to times a 60 here. And what we're doing here is actually times a 1/60. So let's see. Yeah, so what we're doing is 30 times 1/60 milliliter per second. And this will just be 0.5 by this calculation as well. So we can always start from others. We don't need to like always start from the beginning, but we can use the what we have previously as well. So how we can apply the rates is you can see for this problem is we have the like back to our sprinters problems. If we can run with a speed of 10 meters per second. And if we maintain this speed, of course, we won't change the speed at any times. It's asking how far can we run in 15 seconds. So it will be easy because we're just applying the rates here. So it will be 10 meters per second times the interval we have. And it will be 150 meters here. So, okay, actually I don't have the other slides here. And similarly, we can also apply the speed like by any times we can have. So if you are wondering for 15 seconds, I can also calculate this number by thinking about it ratially. So maybe we have 10 meters, like 10/1 equals 2 meters per second. And then I want to change the the denominator to 15 seconds. Because for this question, we have 15 seconds here. And the meters should also be times by 15 as well. Therefore, we know that if we have 10 seconds, the ratio will be 150 meters to 10 seconds. And we can directly get our answers as the ratio, like that, calculating it ratially. So this is just another approach. We can think about the rates here. But it's just something we need to be careful. Where the rate of 10 meters per second, where the speed of 10 meters per second is not the same rate as 10 seconds per meters. So that's something different. Where I should rewrite it, 10 meters per second is not equals to 10 seconds per meters. Any question about it? Because we can also check if we have the right, I guess check the first one will be 10 meters over 1 second. And the second one will be 10 seconds over 1 meters. And we cannot directly put them to a ratio because the units will be different. So I can reverse, like flip the fraction for the second one, maybe. So it will be 1 meters per 10 seconds. So for the second rate, if we are calculating it meter per second, it will just be 0.1 meter per second. But for the first one, it is 10 meter per second. So here we always need to take care of our units as well. So that's something we need to be clear about, carefully with applying the rates. And now it comes to the unit rates problems. So for unit rates, we can usually have a unit rates. Here's a long wording, but I will just highlight it. The most common using a unit rates will be unit price, which means that 1 unit, like how much will cost for 1 unit. And we can also have the amounts per dollars as well, which means that if we have $1, how many amounts we can purchase. So we can think about it. For the second one, it is more kind of like a weighting things. If I want to buy, maybe you can think about I want to buy some rice, like the raw rice here. I want to buy maybe $10. I only have $10. I want to buy some amount of maybe rice, or maybe I'm going to fill our gas while you're filling your car. Maybe there's a prepaid method, and you maybe chose me $10. I want to fill only $10 gasoline here. So it will just be some amount of the rice with $10. But for unit price, it means that if I'm going to the supermarket, I say I want to buy a bottle of water. I cannot let the sellers here to say I want to buy maybe only 10 liters of waters. So I need to like maybe open the package of like a bottle, and then I only getting like the amounts I want. So that's not working here. So we also have a unit price, which means that I have for 1 unit, maybe 1 bottle of waters, I need to pay for maybe $2 here. So that's some differences here. Any problems with amount per dollars or unit price? Okay, so or I can say 1 bottle of water or 1 can of Coke maybe equals to $3. Well, if I cannot say that I only want to purchase $1 of Coke, I cannot divide the can of Coke into 1/3 because others will need to like pay for a open packaged Coke here. So that's the differences for unit price or the amount per dollars. While the amount per dollars is while you're going to the I forgot the like the bar, I think like what's the shop name? I think it's called some bars here. So you can wait for any like amount you want. You can just pay for maybe $10 of rice or $10 of some sauces you want. You can divide whatever you want to pay for that things. Yeah, so for the first thing is well, we have amount per dollars. I have like an example here. So here it says that David's Deli sells 620 grams of salmons for $18. And Fresh Fish sells for 60 grams for $13. Here it says we want the fish to be in similar quantities. Which one has the better values? How can we check which one will have a lower price here? So that's definitely correct. So we'll check the unit rate per dollars here. So maybe for the first one, we have the Davis here and the amount per dollar, I would say, well, equals to 620 over $18 here. So it will be the grams per dollar. And what I get will be approximately 34.4. Actually not this one, but grams per dollar. And while for the freight, I can do the similar things. So amount per dollar, well, equals to 460 over 13 here. And the units will still be grams per dollars. And after calculation is approximately 35.4 gram per dollar. So now we can know that for the same quantity, how much like which one have a better price here. Right. Yeah, because if we are paying for the same amount, we will get more quantities for freight. So freight has a better price. So it means that for each additional dollars, we will receive more amount from freight. So that's what we are comparing for this kind of problem here. And then we can always have the amount per unit, where we can always change to for 1 unit, what's the price for that? And while the lower price will mean a better price, because if I can have 1 kilograms of maybe rice here, I only need to pay for lower dollars here or lower money here to receive the same kilograms. So it'll be like a vice versa ways, like a reverse thinking way. So we always want to check a lower number or lower money we need to pay. So that's the differences for amount per unit and the amounts per dollars here. Any questions here? Okay, so I have a several practice questions as well. So for first one, we are asking for Jenny. So I'm asking for the per day. So we want to divide it by the days here. So maybe 144 over 7, not 7, but 6. and this will be sheep per day. And what we'll get here will just be 24 sheep per day. And for second one, it's asking if like Jenny continue with this rate, how many sheep would she be available to share in 25 days? So we're just applying the ratio here. So this will be applying, so we'll have 25 days times by the rate. Sheep per day. And after calculation, it should be 600 sheep. And similarly, what's the rate per day Sean share sheep? So for Sean, we should also do a similar thing. So 115 sheep over 5 days. So it will be 115 the sheep per day. And we'll get 25 sheep per day. Actually, let's see. 23 actually. Sheep. Sheep per day. So who share the sheep at a faster rate here? Yeah, Jenny, because for each day she can ship one more share one more sheep here, so Jenny will have a faster rate.